In this video, let us continue to solve problems based on first principle of mathematical induction. And we've got a problem here which says, using the principle of mathematical induction, prove that 1 times 2 times 3. Well, for your information, these dots represent the multiplication sign. So 1 times 2 times 3 plus 2 times 3 times 4 plus dot 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 plus n times n plus 1 times n plus 2 is equal to n times n plus 1 times n plus 2 times n plus 3, the whole divided by 4 for all values of n belongs to n, the natural numbers, right? So again, this may seem a little lengthy and different from the previous problem, but the concept is entirely the same. So let P of n be the statement 1 times 2 times 3 plus 2 times 3 times 4 plus dot 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 plus n times n plus 1 times n plus 2 equals n times n plus 1 times n plus 2 times n plus 3, the whole divided by 4. Alright, now the step 1 is we need to have P of n as 1. So what we are going to have is P of 1 will be equal to. Now P of 1 doesn't actually mean just 1. It means the number of terms. That's what it means. The first term, the second term, and so on. So the first term is nothing but 1 times 2 times 3 equals n times n plus 1 times n plus 2 times n plus 3, the whole divided by 4, where n is equal to 1, right? So 1 times 1 plus 1 times 1 plus 2 times 1 plus 3, the whole divided by 4, which is equal to, okay, 1 times 2 times 3 is nothing but 6. Now we just have to see if this is 6. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. So 2 times 3 times 4. 4 and 4 gets cancelled. 2 times 3 is 6. So therefore P of 1 is true. Well, the reason I'm not really solving this is how you're supposed to show it. You know, you don't have to actually show 6 equals 6. This is pretty much understood. But for your own satisfaction, you can definitely solve this, in the right hand side somewhere as a working space. You can definitely do it and check for yourself. This is equal to this, and therefore P of 1 is true. The next step, obviously, is we need to assume that P of m is true. And in that case, we'll have P of 1 as a statement which is 1 times 2 times 3 plus 2 times 3 times 4 plus dot 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 plus, in the place of n, it'll be m now. So m times m plus 1 times m plus 2 equals m times m plus 1 times m plus 2 times m plus 3 times, the whole divided by 4. So now, it'll be P of m plus 1 as a statement which is 1 times 2 times 3 plus 2 times 3 times 4 plus dot 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 plus m times m plus 1 times m plus 2 plus, in the place of m, it'll be m plus 1. So it'll be m plus 1 times m plus 1 plus 1, which is 2, times m plus 1 plus 2, which is m plus 3, right? That should be equal to m plus 1, m becomes m plus 1, m plus 1 becomes m plus 2, m plus 2 becomes m plus 3, and m plus 3 becomes m plus 4, the whole divided by 4. So this is what we have to prove. This is just what it is going to look like, but we need to really prove how is P of m plus 1 equal to this. So which we will do it on a new page because we do not have sufficient space here. But before that, what I'd like to tell you is we need to again see that this part in this should be replaced by this. So when I write it like that in the new page, do not get confused. What I'm doing is, you can see that this is equal to this, right? So I'm replacing this entire part by this. So that's what I'm going to do. Here, what we're doing is we are going to prove that P of m plus 1 is also true. All right. So what we have is, we had 1 times 2 times 3 plus 2 times 3 times 4 plus dot 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 plus m times m plus 1 times m plus 2 equals m times m plus 1 times m plus 2 times m plus 3 divided by 4. So now this whole part is equal to this, right? So if you remember, the p of m plus 1 was 1 times 2 times 3 plus 2 times 3 times 4 and so on till here, plus m plus 1 times m plus 2 times m plus 3, right? So this part will be replaced by this for p of m plus 1. So that's what I'm showing you here. So m times m plus 1 times m plus 2 times m plus 3 divided by 4. This part is replaced by this, plus, as far as the p of m plus 1 is concerned, we have m plus 1 times m plus 2 times m plus 3. So we just have to solve this and get m plus 1 times m plus 2 times m plus 3 times m plus 4, the whole divided by 4. Now as you can see, comparing these two terms, we have m plus 1 times m plus 2 times m plus 3, the same in both the terms. So taking out m plus 1 times m plus 2 times m plus 3, what we have left out is we have m by 4 left out when you factor m plus 1, m plus 2, m plus 3, and here it's going to be just 1, right? So here it is. So now continuing here, we have m plus 1 times m plus 2 times m plus 3 times, this will be m plus 4 divided by 4, right? Which is equal to m plus 1 times m plus 2 times m plus 3 times m plus 4, the whole divided by 4, because it's just simple multiplication. So hence proved, because this is what we needed. If you go back to the previous page, you can see that, we had to prove that p of m plus 1 equals m plus 1 times m plus 2 times m plus 3 times m plus 4 times divided by 4. Or in simple terms, we had to replace, just see this, in the place of n, there had to be m plus 1. So it'll obviously be m plus 1 times m plus 2 times m plus 3 times m plus 4 divided by 4, which is exactly what we've got here. So therefore, hence proved, and therefore, p of m plus 1 is very much true. And we've also proved that 1 times 2 times 3 plus 2 times 3 times 4 plus dot 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 plus n times n plus 1 times n plus 2 equals n times n plus 1 times n plus 2 times n plus 3 divided by 4 for all values of n belonging to natural numbers. Alright, so that ends this problem. So we will, and hence the video as well. So I'll see you in the forthcoming videos with more problems based on the first principle of mathematical induction.